Hello, everybody. I'm Daniel from University of Copenhagen, and together with my colleagues Hansa and Bato from Malmo University, we're going to introduce MBOX, or Multimodal Learning Analytics Box. We know there's a lot of technical challenges in multimodal learning analytics. The systems are specialized, they can be expensive, they're very hard to use in real-world learning environments, and generally they might focus on behavior or performance, and they're not always applicable to collaborative learning in school, or collaborative problem solving, or open-ended tasks, or the dynamic nature of what happens in a real classroom. So what we decided to do is build MBOX. MBOX is a lightweight IoT MMLA system. It's multi-layered architecture, works in the cloud, fog, and on the local system. It's scalable, decentralized, it's adaptable, and hopefully lower cost. It uses different types of sensors, from computer vision to biometric sensors to audio sensors and whatever types of sensors you want to hook up to it. It runs on diverse hardware, from small single-chip computers and microcontrollers to larger multi-threaded devices. This is the overall conceptual architecture of MBOX. And on one side, you have the inputs of audio, video, positioning, service, and biometric running into a small type of device using TimeFlux in the case that we're going to present, which is an open Python framework for biosignals and other types of sensors. And of course, it also records from the mobile and learning objects. And then there's, in a sense, on the cloud or in the fog, there's the database. And then we're able to apply different types of machine learning, create visualizations, give constructed feedback, and finish the loop back towards the learners. This is the different types of hardware we've been experimenting with. Let's see, would be on the left side of the screen, you see Arduino-based Seed, a Max Cube, capturing video. You see Raspberry Pis with the res speaker in the center, and NVIDIA Jetson with a camera, and then of course TimeFlux showing some sample brainwave capture. Of course, this wouldn't be possible without my students from last semester who worked really hard on developing this proof of concept, and these are the people from Jesper to Johan and everybody in between. A big thanks to them. And this is what they worked on, which is a proof of concept, which is what this demo is about. So we have a sensor that goes to the Raspberry Pi. We have different types of sensor. We used Bitolino, which is an open source biometric system. We did different types of computer vision with video and different types of audio. They were strung out to TimeFlux or straight to Influx and visualized in Grafana. This is the MBOX system, and what you can see running on the cloud are different measurements, and then a visualization in Grafana, in this case capturing the faces. And you can see sort of what's happening a little bit with what we've been thinking about in terms of time series. This is a short demo of measuring a distance between two faces during lockdown, and the visualization within Grafana. And you can see that there is some ability to capture different types of features, like the distance between a real face and a fake face. In this case, we looked a little bit at pose optimization using the Raspberry Pi, and you can see a little bit happening here with Johan's work. Of course, skeleton tracking is complicated while sitting, and of course there are different kind of features as well, and you'll see in a moment, of course, very much like the ability to capture a fake face. Pose estimation can actually capture your imaginary classmate as well, in the case of the doll example. So there are definitely still challenges within this system. We also explored object detection, in this case trying to capture when somebody is in a Zoom meeting and using their mobile phone. And you can see that it works fairly decently on the Raspberry Pi as well in MBOX. We also looked a little bit at biosignals. This is the open source Bitolino, and you can see in this case that Jesper is capturing some of his muscle contradictions and recording that into the time series database. In this case, directly through a laptop. A little bit in terms of the voice standardization and automatic speech recognition. And here you can see, in this case, it's cloud-based using Google Cloud Services to sort of process the video stream live. Although we're working on updating this a little bit, somewhat accurate, but at least it gives you some idea of what's possible with these low-cost systems. What we're working on for the spring is embedding a little bit of teeny machine learning onto smaller devices. In this case, this is the Arduino Vision Shield for the H7 Potentia board, and creating more what I would call nudge devices. So in a sense, capturing something on a granular or rough granular level to give reflection and action in group contexts, and to look a little bit at productive failure. How do you create learning situations where together with the devices, the group can give feedback and can experience what's the key thing in learning is productive failure, risk-taking, and fast and slow thinking. So thanks. Here's some updates on the different types of technology. We'll be using Edge Impulse this spring and continuing the flow to influx and time flux. So thanks from the University of Copenhagen and from Malmo University, and look forward to discussing ways that this can be expanded and used.